Good morning to one and all. My name is Vamshi. I'm from Triple E Department, bearing room number 23955A02226, Vamshi Gaur. Today I'm discussing about a topic of energy apps for the future. Coming to introduction part to for this topic, introduction to future energy apps. Energy apps are centralized facilities that integrate multiple energy sources and carriers. They aim to optimize energy production, storage, and distribution for efficiency and sustainability. The future of energy apps involves advanced technology, smart management, and renewable integration. The mainly future energy apps are mainly discussed about the smart management and the renewable integration purpose only. Definition and concept of energy hubs. An energy hub acts as a nexus where various energy vectors such as electricity, heat, and gas converge. They facilitate flexible energy management, balancing supply and demand cross sectors. The concept promotes decarbonization and enhances energy security through integrated system. They mainly this focus on the renewable energy resources which is non-pollutant to the environment and which will be utilized many times, which is not completely exhaust. And the key components of future energy hubs. Renewable energy sources like solar, wind, and hydro will be primary inputs. Storage technology such as batteries and thermal storage will enable energy buffering, conversion, and distribution infrastructure will connect a different energy carriers. Here we can see in the picture we can see the different types of energy power plants we can see as from factories and there will be hydro and industries will be uses many of the electricity which is provided from the power plants and vehicle which is be used for electric vehicle for the charging purpose, etc. Roles of renewable energy in energy hubs. Renewables are vital for reducing greenhouse gas emissions in future energy systems. Energy hubs will maximize renewable energy utilization through smart integration. They will enable better management of intermittent renewable sources through storage and flexibility. Renewable energy which can be reused again and again, which will be not completely closes and which will completely over and which will be environmental free and by damages and store energy storage technologies. Battery systems including lithium ion and ion will provide short-term energy storage. Thermal storage will optimize heating and cooling needs within hubs. Power to X technology will convert excess electricity into fuels or chemicals for storage. Here we keep seeing that the battery systems which can be seen that an energy which is supplied from the power plant and it can be stored in temporarily for in a battery for a temporal purpose and we can store a large amount of energy we have to store in thermal storage which we can optimize heating and cooling needs in this also. Smart grid and digital technologies. IoT sensors and advanced analytics will enhance real-time monitoring and control. Artificial intelligence will optimize energy flows and predictive maintenance. Digital twin models will simulate and improve energy performance before implementation. Sector coupling and integration. Energy hubs will connect electricity, heating, cooling, and transportation sectors. Sector coupling will lead to increased efficiency and reduced emissions. Integrated systems will support the transition towards electrification of various sectors. Integrated systems will support the transition towards electrification of various sectors. Smart grid and digital technologies. IoT sensors and advanced analysis will enhance real-time in monitoring and control. Artificial intelligence will optimize energy flows and prevent maintenance. Digital twin models will simulate and improve energy performance before implementation. Decentralization of energy hubs. Future energy hubs will increasingly be decentralized to serve local communities. Distributed energy resources will empower prosumers and enhance resilience. Decentralization helps reduce transmission losses and improve grid stability. Microgrids and community level hubs. Microgrids will operate semi-independently to provide local energy security, whereas community energy hubs will faster local renewable energy generation and sharing. These systems promote energy democracy and localized sustainability. Policy and regulatory frameworks. Supportive policies will be crucial for the deployment of advanced energy hubs, and regulatory frameworks must enable market participation and innovation. International cooperation will accelerate technology development and deployment. Economic benefits of future energy hubs. For the economic of the our world, they will be utilizing future energy hubs. They can reduce operational cost through optimizing energy management. We can reduce a lot of cost which can be used for optimizing energy management, and we can use energy hubs will create new job opportunity in renewable and tech sector, and this hub also creates a new job for the unemployment people, and they get a lot of employ opportunities for the to creating something new which can be used in renewable and in tech sectors also. They promote economic resilience by diversifying energy sources and supply chains. Challenges and barriers. High initial investment cost may higher widespread implementation. Technical complexity requires advanced skills and infrastructure. Regulatory and market barriers can slow down adoption and integration. Case studies and pilot projects. Several pilot projects demonstrate the potential of integrated energy hubs in the worldwide. These projects showcase technologies like hybrid renewable systems and storage systems. Lessons learned inform the design and scaling of future energy hubs. Case studies and pilot projects. Several pilot projects demonstrate the potential of integrated energy hubs, and in the worldwide, these projects showcase technologies like hybrid renewable systems and storage purpose also. Lessons learned inform the design and scaling of future energy hubs. Advanced in technologies innovations on the horizon. Advances in artificial intelligence machine learning will enhance energy management systems. New materials and storage solutions will appear efficiency and lifespan. Integration of blockchain could facilitate secure transparent energy transactions also. Environmental and social impact. Energy hubs will significantly reduce the carbon footprints of local communities. They can improve air quality and also public health through cleaner energy sources. Social acceptance and community involvement are vital for successful deployment. Here in this we can they can improve the air quality and which is environment free, which will not affect any environment, and which can produce health through cleaner energy sources from the environment. Social acceptance and community involvement are vital for successful deployment. Future outlooks and trends. There will be seen a trend toward more integrated, flexible, and resilient energy system which accelerate. Digitalization and automation will play a critical role in managing and complex energy networks. Collaborative efforts among stakeholders will be key to realizing energy hubs for potential. And the role of governments and industry which we have to keep conforming this. Governments can incentivize innovation with subsidies, standards and policies. Government should encourage the people to do give subsidies and standards and policies to the people to keep developing this energy for the better development of future needs. Industry partnerships will drive technological advancements and deployment, and a public-private collaborations will be essential for scaling energy for hubs globally. And of all of the people have to be collaborate with each other to keep growing energy hubs for the future needs. To strategies for implementation. Developing comprehensive planning frameworks will ensure effective deployment. Investing in research and development will foster innovative solutions. Community engagement and education will promote acceptance and participation. And coming to the conclusion of the further energy hub for the future needs is will be energy hubs are central to achieving a sustainable and resilient energy future. Embracing technological and policy innovations will accelerate adoption, collaboration across sectors and borders is essential for realizing their full potential. Thank you.